Functions. One parent function that you're going to have is just the graph of a line. Do you know what the equation for a line looks like? Y is equal to mx plus b. If you have something in that format, that's actually the slope y-intercept format. If you have something that looks like that, it's going to be an equation of a line. The key thing about the equation of a line is you're going to have x, y variables, giving it two dimensions, which we have the x and the y axis, also known as abscissa ordinate. We're to look at it that way. The x-axis here is also known as the abscissa. The y-axis, also known as the ordinate. Okay, so if you have the x and y axis, generally for the parent function, what happens with the parent function is it's saying, this is what you have for the graph, but then you can manipulate it. You can do something to it to move it up. You can do something to it to move it down. You can do something to it to shift it over to the right or to the left. And it's all how you manipulate this equation right here. Now, this is only one form for an equation for a line. Another form for an equation. The thing about it is you have x and y. Those are your two variables. M is going to be a constant, which is your slope. B is going to be a constant, which is the y-intercept. So that's slope y-intercept format. Another form for an equation for a line is the point slope format. Point slope format is going to be y minus y sub 1 is equal to m times the quantity x minus x sub 1. And when you talk about that, this right here is your slope. This right here is your y-intercept, where it crosses the y-axis up. This right here is your slope. And then you have a point, because this is point slope format. Point slope format. The point you are working with is actually x sub 1, y sub 1. So you will have, I'm going to highlight where numbers will actually be in your problem. So there's a constant, there's a constant. Those 2 points will be a constant in the slope. You have x and y, those two variables, but they will be raised to the first power. That's one thing that's also going to designate that parent function. That second equation, where it's in the point slope form, you're going to become quite familiar with. And you're going to find out it's probably pretty nice to use instead of the slope y-intercept. If they give you a point and they give you the slope, you can directly put it in here and be done. If you want to rearrange it, you can, and you can still graph from here. Even though you guys know you find the y-intercept and then you rise over run to find the other points. So there's our first parent function, which is a line. Can I change that slide? The next parent function that we have, what's important to recognize, is going to be take your x-y axis, and the next parent function that exists is when you have the two variables, with one being to the first power, the other being to the second power. Do you know what the graph of that looks like? A parabola. And if you wanted to make whenever you want to graph, the key thing that you can do is just create an XY table. You pick values for x, put it into the equation, and find your outputs, and then plot those points, and you have your graph. So if I have -2, what's -2 squared? 4. If I put -1 in, -1 squared is 1. If you put 0 in, you get 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. You could do -3 as well. So if I want to plot those points at -3, I think I'm going to run into my words, 2, 4, 6, 8, 9. Maybe I should do it in green. Then we have the point at -2, you get 4. At -1, you get 1. At 0, you get 0. At 1, you get 1. At 2, you get 4. At 3, you get 9. And you get your parabola form. So whenever you see a y and an x squared, you have a parabola. That's one thing you've got to recognize, which is going to be the U shape, not to be confused with the V. The V is going to be something else that leads you to that graph. So as we look at that parent function, there's going to be different things that you can do that are going to cause it to shift up, shift down, to the right, to the left, and you can also do something to flip it upside down. So we need to know when I do certain things to this. We can also do something that's going to cause it to stretch upward. Austin had texted me Monday night and asked me a question, and it was, when there's a coefficient of 2 in front of there, does it stretch it or does it widen it? I think were the two questions he asked. And so I'm sitting here and I'm recording like I am right now and sending it to him. And in the meantime, I'm like, so if you get a coefficient that's greater, then you go like this. And I'm like, well, you just couldn't see what I did. But that's what happens to it. As this coefficient in front of 2 or in front of x gets larger, then it's going to cause it, you got to reach up higher. So it makes it skinny instead of making it fat. If this is a number between 0 and 1, it's going to make it wide. If the coefficient is negative, it makes it a frown. If you have the quantity x plus 2 squared, it shifts it to the left. If you say x squared plus 2, it shifts it up 2. So those are things that we need to be able to recognize and know what the parabola is going to do. But parent function means recognize when you have y equals x squared, it's going to be a parabola that opens upward. Now with that, you could switch it, and you could say x is equal to y squared. That's going to open up like this. It's going to be a parabola on the positive y-axis. But that's not considered a function, because we'll get to what actually classifies functions. And one thing for that is vertical line. Now, something else I said is don't let that parabola be confused. It's a U. Don't confuse it with a V. So that leads us to another parent function. And the next parent function you have is y is equal to the absolute value of x. And if I were to look at that and plot some points, so I just picked values, x values of -3, -2, -1, 0, 1, 2, 3. The absolute value of -3 is 3. -2 is 2. -1 is 1. 0, 0, 1, 2, and 3. So if you plot those points, you're going to have the point 0, 0, -1, 1, -2, 2, -3, 3, 1, 1, 2, 2, 3, 3. And your graph now is a V. It is not a U. The parabola happens to be y equals x squared. Now the same thing with this, we can do different things to cause it to flip upside down, shift it over, put the vertex in whatever quadrant we want. Those are the translations that happen, but as long as you can recognize when you see an absolute value, you're going to get a V, you're doing good. Another common one that you are going to have. And I do believe some of these maybe not. I thought you would have some of them. on your paper. But another one that you're going to have, if you flip over, I don't know how well you can see it, but you turn to page 15, and they're going to put a couple, actually they just kind of have a parabola there and give you some transformations. But another parent function that you can have that it's important to recognize the shape of. What if I give you y is equal to x cubed? You think about y is equal to x cubed. If I tell you, what if x is -3? What's -3 cubed? -27. If you put in -2, what are you going to get? -8. If you put in -1, -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. Now, I'm not going to be able to graph this on here very well because I'm not going to be able to go down to 27. But at 3, I get 27. At -2, I'm going to go to -8. At -1, I get 1. Then you get 0. Then you're going to get 1. At 2, you get 8. That's 6. Did I go 6 here? 2, 4, 6. Yes, I did. 2, 4, 8. Right down here. And then you have 27. So what your graph of a cube looks like is something like that. Keeping in mind, this is going to go up to 27. So when I move one more over, I got to go up from 8 to 27. So this is the general format for an x cubed graph. Now on the same one, I am going to graph as another parent function. What about y is equal to the cubed root of x? If y is equal to the cubed root of x, we want to pick our numbers just a little bit differently. Can I take the cube root of negative numbers? Yes, you can. You can take the cube root of negative numbers. And I probably should do this on a separate one, and I'm going to go back and do the square root graph. But if we talk about the cube root of -8 is -2. -2 times -2 times -2 is -8. If I picked -27, even though this is out of order, that would give you -3. And that's going to bother me, so I'm going to put them in order here. Smallest to largest. It is. It can be another parent function. Yep. Recognizing what the typical graph of a cube root is going to look like. -8 is going to be -2. At -1, you're going to get -1. At 0, you get 0. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. So if you look at the graph of that, you have to go x is -27. Let's clear back over here. And I'm going to go down to -3. Then when x is -8, I get -2, which is right here. At -1, I get -1. At 0, I get 0. At 1, I get 1. And at 8, 2, 4, 6, 8, I get 2. So the parent function for this is still something kind of similar to what you have, except for it kind of veers in the other way. Instead of going, you're going upward, but you're going to the left or to the right, instead of going straight up or straight down. So there's a parent function as well, and that's the cube root. Now we can go, are we okay with that? Can I change? Another parent function that we can have, I better go back and fill this one in, is the square root. I have to do it in red or something. Purple. I don't know what color. because I wrote in blue but put it in green. That didn't work so well. Another parent function we have, let's do it on a separate slide, is the square root function. And we want to know if I have a square root, what is the typical graph I can look at for a square root? The square root has a certain domain. And I know that some, like I said, Lindsay has not done anything on the computer, but I know that there's some classes at UNL that are on the computer, because I've gone to UNL Math Day, and then I have kids come to the dorm rooms for help. And I've seen what they go through for some of their questions for homework. And one thing is just being able to recognize, given graphs, what equation matches that graph, multiple choice. Given an equation, multiple choice, which one of the graphs is the graph of that equation? So if you know something with parent functions, you can narrow it down to probably a couple of choices. You just got to know the parent functions and then how certain things manipulate it. So the other parent function, y is equal to the square root of x. Pick some values to graph it. If you look at x and y, we're going to say the square root of -3, -1. Let's go even better yet. Let's just go to -4, -1, 0, 1, 4, 9. What's the square root of -4? Yeah, it's an imaginary number. It's going to give you an error on your calculator if you were to do it. That's the same thing as 2i. Not going to be able to graph that imaginary number right there. -1, that's going to give you an error. You cannot take the square root of a negative number. 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Now keep in mind, normally if you're solving an equation and it's x squared equals 4 and you go to take the square root, you have to do plus or minus values. But right now, if they wanted this to be a negative, they would put a negative sign in front of it. So the square root of 4, the only thing that this equation is looking for is that positive value. Square root of 9 is 3. So if I start to plot those points, the domain is that x has got to be greater than or equal to 0. I cannot pick a negative number and take the square root of it. So you get the point 0, 0. You get the point 1, 1. When you are at 4, you get 2. When you are at 9, you get 3. And the parent function for a square root graph looks like that, right there. You kind of just get an arch that goes over this way. That's a parent function. So when you see that, you're going to say, oh, that's a graph of a square root. You've got to be able to go through and look at these and say, oh, that's a graph of a cube. Go the other direction. That's the graph of an absolute value. There's the graph of a squared, x squared. And of course, then you just have the graph of your line. So those are main parent functions that you need to look at and at least recognize a little bit about what the equations are, known as parent functions. Maybe I should get rid of this. That's me confused. You can manipulate it. You can negate it in front. If you put the negative in front, it's going to, in front of the radical sign, it's going to curve it. It's going to curve it like this. Okay. If you put the negative underneath the radical sign, you're going to get something like that. If you put the negative underneath the radical sign and underneath the radical sign and out in front of the radical, you're going to get something like this. So there's lots of ways we can manipulate it to be able to look at what's happening with my graph. But the key thing is it's still going to be the graph of a square root. It's just how have I changed it, but still have that general form for the graph of a square root. Okay. All right, so if we just ask you to graph lines, You can't see the translations as well with this. But if I tell you to graph the equation y is equal to 1/2 x minus 2, how many of you would create points, pick values for x? If you have a fraction there, so that you're not graphing fractions, you would probably want to pick multiples of this denominator. So you can pick like -2, 0, 2. What's -2 times 1/2? -1. Minus 2 is -3. If you put 0 in, 0 times 1/2 is 0. Minus 2 is -2. And if you put 2 in, you get 2 times 1/2, which is 1. Minus 2 is -1. So if we were to graph, we could always, a backup, is come up with this right here. The other thing you could do is you can recognize what's this right here. What's that represent? The y-intercept. So we're going to go vertical, and it crosses at -2. Then we can look at this right here, and what's that tell you? Slope. And we remember with slope, this is a what slope? That's a positive slope. And if I look at this, what slope is that? That is a negative slope. And we remember that because it forms the N when you're talking about the word negative. What is this right here? What's the slope of a horizontal line? 0, because we know that we can get the word 0 out of it. And what type of a slope is a vertical line? A vertical line is undefined. And we know that because that 1/2, that 1/2 is referring to rise over run. So from any 2 points on your graph, you're going to go up 1 and over 2. Rise over run. So from this point, I go up 1 over 2. So up 1 over 2, and there's another point on my graph. Positive slope, that means I got to veer off this direction. That's why I know I don't go back 2, is because I need that positive slope. I could go down 1 and back 2, because when I connect those, that's still going to give me the positive slope. Up 1 over 2, up 1 over 2, down 1, back 2, down 1, back 2. And when you connect those, you get the graph of your line. Now, if we look at referring to the table of points that I had picked, at -2, you get -3, which is that point right there. If you look at 0, I get -2, which is this point. And at 2, I got -1, which is this point. Now, you could put 1 into your problem, but you're going to get 1/2 minus 2 is 1.5, and it's going to be really hard to determine where 1.5 is right there, or where -1.5 is right there. So it's easier if you just pick the positive and negative values of that denominator, multiples of that denominator. But I'm guessing most of you would just go, here's -2 and rise over run. Is that correct? The problem people have is, remember that y-intercept is here, not here. Now, I know one thing that they are asking, here's another way that you could graph it. Another way that you could graph it is by looking for intercepts. If I ask, we already know the y-intercept is -2. Where does it cross the x-axis at? What's the x-intercept? 4. It crosses the x-axis at 4. If I talk about any point on the x-axis, what does any point on the x-axis have in common with another point on the x-axis? Y is 0. Any value on the y-axis, what it has in common with another point on the y-axis is x is 0. So another way you could graph it is based off of the intercept method. And if we look at the intercept method, which is a key thing that they're stressing at college, because Lindsay's already had it, so I know, is they want to know what are the intercepts. And you can graph it by just finding the intercepts. To find the intercepts, either x is 0, which is your y-intercept, or y is 0, which is the x-intercept. So this is the y-intercept. Where does it cross the y-axis at? And when y is 0, that is the x-intercept. Where does it cross the x-axis at? So you go back to your equation and you say, well, I want x to equal 0. So if I take the equation, y is equal to 1/2 x minus 2, and if I let this be 0, 0 times 1/2, that wipes this out, and you get -2. Well, we know that that's given to us in the equation, and we already plotted that point. So I could plot that point if I wanted to. Then if I find the x-intercept, y equals 1/2 x minus 2, what you need to do to find that x-intercept is you have to let y be 0. So I'm going to replace that in my equation, and now you solve that equation. So you add 2 to both sides, and you get 2 is equal to 1/2 x. So you divide by 1/2, and if you divide by 1/2, that means you multiply by 2/1, and you get 4, which is what we had when we were graphing in another method. Now, how many points does it take to graph a line, to determine a line? How many points does it take? 2, and I have the 2 right there. If you're confident about those 2, you can graph your line from there. And I can say, yep, that's great. Right there's my line. Okay. You can have the slope, count your slope, find the y-intercept, and go with your slope from there, or you can create a table of values. If you create a table of values, I always recommend 3 in case you miscalculate one of them. Then your points aren't in a line, and hopefully you recognize it should be a line because you have x and y both to the first power. So it should be a graph of a line.